and welcome. Today we're going to be solving a linear quadratic system of equations. Now we've been solving systems, and the systems that we've been solving have been two lines, and we're looking to see where they cross. We also graphed linear inequalities, and we graphed two inequalities or even more to see where they crossed. In this case, we're going to have a linear and a quadratic. So this line represents our linear, and this blue parabola here is our quadratic, and you'll notice we're going to look to see where they cross. Well, if you take a look at that, it looks as though they cross twice. They intersect at 2 points. So this has two solutions. If I move this line up here and just ever so slightly touches it here, it's going to touch it once. So this one is going to have one solution. And it is possible that maybe this line sits a little bit higher than that parabola that faces down, and that would have no solution. So if you're someone who's taking notes on your own piece of paper, don't worry about any of these paragraphs or anything else like that. What I want you to worry about, or just jot down, is what does it look like if it's a no solution? If it's a no solution, then essentially you'll have a parabola, and you'll have a line that's going to go something like that. It won't cross. There's no way it can cross. One solution would mean that you have your parabola in either direction here. I'm just making a sketch. And your line would say just touch this right on the side here. That's going to have one solution. And that one solution would be right here where they cross. It is also possible for you to have two solutions. So maybe you have your parabola here, and you have your line, and it cuts through it, say something like that. Just like that. That would be an example of two solutions. There you go. There are my two solutions. So the only thing I would love for you to write down is just a no solution, make a sketch, one solution, make a sketch, and two solutions, make a sketch. Now let's take a look at a model problem. Let me walk you through a model problem. And again, you don't have to print these. You don't have to take notes. You can just sit back and watch. All of my notes are completed online, so if you ever want them, you can print them from online when school gets back. So if you want to just sit back and watch, go for it. But I'm going to start with graphing the linear portion because that to me is the easiest to graph. So this one is my y-intercept. My slope is right here. Change in y over change in x, if you remember. Up 1 over 1, up 1 over 1. It's helpful to make lots of dots in this case because we're going to be looking to see where they intersect. I'm going to draw my line. Now we're going to put more than one graph on here, and hopefully you remember what I've told you in the past. Anytime you're going to put more than one graph on a coordinate grid, you're going to have to label it. So I'm going to label it. Now let's do the harder one here. Let's do the quadratic. In the previous lesson, we learned how to graph this, and we used our graphing calculator to help us. Essentially, what I want you to do is find the middle, and that's this axis of symmetry. And here we have this formula, which comes from the quadratic equation. Now you've got to know what A and B are. So A is actually our leading coefficient. So A is going to be 1. B is the coefficient on the linear term, so that would be positive 2. So this is going to be negative 2 all over 2 times 1. So ultimately x is negative 1. So I'm going to make a table of values. Let me draw that a little bit nicer. I'm going to make a table of values here, and that negative 1 is going to be the middle. Ultimately, it's the middle of my graph. Okay, so let's take a look. I'm going to jump over to my graphing calculator here. If you remember, we're going to go to a graphing page, and I'm going to put the equation in. So that would be x squared plus 2x minus 5. Hit enter. And that's good. I can see what the picture looks like, and given where it is on my screen here, if I can visually transpose it onto my whiteboard, it's going to cross more than once. Looks like I'm going to have two solutions here. So now I'm going to go Control T, because what I want to see is really the table. Those of you who are working on Desmos, a student asked me earlier how you could see the table of values on the Desmos app. So get into my Microsoft Teams page, our Algebra Microsoft Teams page, and look through the posts. You'll find, I put some pictures on there where you can find it. Okay, so I'm just going to steal the values right off of here. So let me go back over. And since -1 is the middle, I'm going to choose some numbers smaller. So I'm thinking -2, -3, -4. And I'll choose some numbers larger, so 0, 1, 2. And I should see some symmetry here with my output values. So an input of -4 gives you an output of 3. An input of -3 gives you an output of -2. Then we have a -5. And right here with the -1, looks like I have a -6. And I'm just going to keep going. And I can see the symmetry here. Perfect. Well, I'm done with my graphing calculator. So I'm just going to plot these points here. Okay, this next one here looks like it's a solution. And there's my other solution. So I'm going to draw my parabola. Hopefully you're a little bit better at drawing these than I am. And I'm going to label it. And it looks like my solutions are 2 points. It looks like the first one here is -3, -2. And the second one looks like 2, 3. So I'm going to show you how to do a formal check here. If you want to do a formal check, you've got 2 points that you have to put in 2 equations. It's a little bit more work. So let's check the first point, -3, -2. So your first equation is y is equal to x squared plus 2x plus 5, or no, minus 5. So that's going to be -2 is equal to -3 squared plus 2 times -3 minus 5. So -2 is equal to 9 minus 6 minus 5. So -2 is equal to 3 minus 5. -2 is -2. I also have to check it in the other equation. So that means -2 is equal to -3 plus 1. -2 is equal to -2. Checks. I have one more point to check. So let's check the 2, 3 point. So 3 is equal to 4 plus 4 minus 5. So that's 8 minus 5. And yes, 8 minus 5 is 3. So that works. And I'm going to check the second equation. This is a lot to check, definitely. So 3 is equal to 2 plus 1. 3 is equal to 3. Perfect. It checks. Great. So that's how you do it graphically. You just graph each of them and see where they cross. Don't forget to label and don't forget to mark your solutions. That's very important. All right, let's talk about algebra. So there were 2 algebraic methods that I taught you, 2 of them. One was using the addition method or subtraction, whichever you want to call it, addition or subtraction, and the other one was substitution. Now, the thing that you need to keep in mind that if you're using the addition method, you would want to rewrite your equation so that y has the opposite coefficients rather than the x. The problem is when you're trying to get rid of the x, you have an x squared and you also have an x to the first power. And since one of them is quadratic and the other one is linear, the linear is not going to have an x squared. You won't be able to eliminate the x's. So because of this, if you're using the addition or subtraction method, you want to make sure you rewrite it so that you're getting rid of the y's and not the x. Okay? All right. The other thing you have to keep in mind here is you might have two solutions. If you have two solutions, remember, you're not just solving for the x values, you're also solving for y values. So I'm going to take this problem and I'm actually going to model it two different ways. The first way is, let's use the addition method. So with addition, you're going to line them up. And we could use addition slash subtraction. Totally up to you. So I lined them up. You see how I have my y's lined up? My equal signs are lined up. I left a space here because I don't have an x squared with my linear, and then lined up the x to the first power and the constants. Now I need opposite coefficients. Here's how I'm going to get them. Multiply the whole thing by -1, which is also the same thing as subtraction. So now I have y minus y, which is 0, equals x squared minus nothing is x squared, 2x minus x, which is x, -5 minus 1, which is -6. Oops, I forgot my plus sign there. Okay, now you have to look at that and say, what kind of equation is that? Well, that's quadratic. So you got to remember how to solve a quadratic equation. Factoring is probably our easiest way. If you remember what multiplies to -6, that adds to 1. Right? Because we're going to have an x here and an x here. So what multiplies to -6 that adds to 1? Hopefully you're saying plus 3 minus 2. So now to make this statement true, this binomial could be 0. Which means x could be -3. Or this binomial could be 0. Which means x could be 2. Which is wonderful, but now I have to get the y values that go with it. So what this means is I have two ordered pairs, right? I'm going to cross at 2 points. The first one has an x value of -3. The other one has the x value of 2. What I need are my y values. I have to get those y values. Okay, so let's do that. I'm going to take these two answers and I'm going to put them back into one of those two original equations. Now, if you're like me, I want to do as little work as possible, so I'm going to put it into the linear one. Start with the -3. So I'm going to put in the -3. So your first answer, when x is -3, your y value is -2. That's an answer. Let's get your second one. This time I'm going to plug in x is 2. So y is equal to 2 plus 1. So that means my y value is 3. Which means when my x value is 2, my y value is 3. That's your second ordered pair. I'd like to do this one more time, but instead of, this is the same problem, instead of doing it the way I just did it, I'd like to use substitution. Just so that you could see how this would work. So if you were going to do the substitution method, the nice thing is they're both solved for y. You have two equations with variables set equal to just one letter. And what I'm going to do for me is I think I'm going to put this right in place of that y right there. So I'm going to do ESA. My equation is y equals x squared plus 2x minus 5. And again, I'm going to put that right in place of my y. So I'm going to put that x plus 1 right in place of my y value because x plus 1 and y are the same number. Okay, now I have this lovely quadratic equation that I have to solve. And I think I want to try solving it by factoring, but I'm going to have to get it set equal to 0. That would be standard form. So I end up with 0 is equal to x squared plus x minus plus 1x minus 6 and again I'm going to solve that. This is exactly where I was in the other problem. I'm going to solve that by factoring. So x plus 3, x minus 2, so that would be your negative 3. And from here, the problem is exactly the same as this right here. You'll notice I came out with the same values right here. So it's the same thing. Let's try one more from scratch. Okay, solve algebraically. If I'm going to solve this algebraically, I think for me what I'm going to do is I'm going to use the addition-subtraction method. So y is equal to x squared plus 2x plus 1. The second one I'm going to line up right underneath it. X equals, I'll leave a space, and then have 2x plus 5. And I want to get rid of the y's. If you're going to use the addition or subtraction method, you have to get rid of the y's. No choice there. So I think we're going to minus, 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 and therefore I get 0 is equal to x squared. These are gone, and that's going to be minus 4. So you could do one of two things. This is an incomplete quadratic. You could solve this by factoring the difference of two perfect squares. So that would be x plus 2 times x minus 2. Or, because it's incomplete, if you remember, you could bring the constant over here, and you get 4 is equal to x squared. And in which case, I would take the square root of both sides. But you have to remember that you're going to get x is equal to plus or minus 2. You should get two answers for a quadratic. Okay, now that we have our first part, when x is equal to positive 2, let's get our y value. You can pick either one of these two equations. I like the easier equation, which is 2x plus 5. So I'm going to take my positive 2 and I'm going to put that in place of x. So y is equal to 2 times 2 plus 5. So that means y is going to be 9. So my first answer, when x is 2, my y value is 9. That's one answer. Now I'm going to do the negative 2. So y is equal to, whoops, 2 times negative 2 plus 5. So y is negative 4 plus 5, which means y is going to be 1. So second answer, when x is negative 2, my y value is 1. Okay, so there we go. I'd like you to try some practice problems. If you go back to my website, you're going to find that there's a worksheet there. Again, you do not need to print it. Just do the problems on your own sheet of paper, and you can check your answers right away as you work. If you have any questions, feel free to send me a message in Teams or email me. Good luck!